Hi everybody. So in this video, or maybe there might be a couple of videos depending on the length, what we're going to be taking a look at is a concept covered in BC Calculus called integrating by parts. This is an advanced integration technique that's used primarily when you want to evaluate a definite integral, but where you're going to be looking primarily at probably some kind of a transcendental function of some form or another. So in the notes that correspond with this video, this is the first thing that you're going to be seeing here, where it's kind of just going back over the idea that, well, with U substitution, the chain rule, those are kind of opposites of each other. Well, what we're going to be doing here with integrating by parts, that's going to reverse the product rule. And here it's kind of showing you again where the product of algebraic, or specifically a lot of times what we're going to be looking at are transcendental functions. And again, those are going to be things where you have trig, logarithmic, or powers of where e is the base raised to some exponent of x. Well, in the notes that correspond with this video, the first thing it's asking you to do, it's asking you to, well, what is the integrating by parts formula going to be? So what we're starting off with, what it's giving you to begin with, is the chain rule. It is, when I take the derivative of u times v, we wind up with this expression here. Well, what it's asking us to do, it says, well, let's take that and try to, integrate both sides of it. Well, we're going to do a little bit of separation of variables also. We want to take that dx out of the denominator and move it to the right side of the equation. And so starting off, we're going to kind of say, let's do the integral of dx time of uv, like that. And we have the integral of u prime v plus the integral of uv prime. Okay, so what I'm going to do is I'm going to kind of get rid of the dx on the left side and multiply it to the right side on both sides. And I'm going to go ahead and integrate on the left side, and we're going to just wind up with uv on the left side here. And I'm going to have the integral of u prime v times dx plus the integral of uv prime times dx times dx. There we go. And so what we're going to be isolating, what we're going to be solving for, is we want to get the u v prime dx kind of by itself. We want to be able to get this guy here by itself. So you can look at it and think that, well, we can take this and move it over here through subtraction, and that's really exactly what we're going to do. So we're going to say u times v will be equal to I'm sorry, not equal to, I am getting ahead of myself here. U times v plus, I'm sorry, not plus, minus the integral of u prime v dx will be, and let's just go ahead and put the equal to part on the left side because that's how most people are going to prefer it written. The integral of u v prime dx. And this is what we're looking at for our formula for integrating by parts. And if you happen to have the notes handy for this, this is exactly what we see here. U times v prime is equal to uv minus the integral of, now here they have it written as v du, which a lot of people will write it or say it that way. V du is a lot easier to say than the derivative of u times v. But the way that I had it written on the last slide was u prime v dx, like that. But that is the rule of what we're going to be looking at here, and this is kind of how I had it written. But that's the formula for integrating by parts. So here are some general guidelines to follow when you're integrating by parts. Let dv be something that's more complicated. so it can be integrated easily. Let u be part of the integrand, that the derivative du is simpler than u. Here we have this acronym, like LIATE, however you want to say it, where this is how you should look at it, and to choose what you should choose for u, if I could get it out. L is going to be a log function of some kind, I inverse trig, A algebraic, T trig, or E exponential. That's how you should look at them in that order. Now, you only have two choices to select for u or v from your function. So if one doesn't work, then go back and try the other one. So here we have our first real example where we want to be able to integrate this particular expression, the integrand of x times e to the x power. Okay, so the first thing we need to be able to identify is what are we going to classify as u, and therefore like dv. Okay, so when we're looking at the function, what are we going to say? Let me just go ahead and write the equation down here. Let me let's go ahead and go with black here. This is what hey, battery's fully charged, awesome. This is what our function is, the integral of u times v prime dx is equal to u times v minus the integral of, oh, my wrist keeps hitting things on my computer. I don't mean to do that. Oh no, what did I do? Go away. Sorry about that. Oh, come on, computer. It's being very touchy now. I've been using it all day and it's been fine until now. So we have, let's try this again. U prime v, or v du, however you want to think of it, dx. So what we're establishing in this function where it says x times e to the x power, what we're establishing is when it says u and v and all that stuff here, kind of in this region here, it's asking, which of those two is going to be u and v prime, or dv, as it shows on the screen or on your paper. Okay, so in this example, and let me go ahead and start with another color here so it can distinguish it from the black writing that I have so far. If I'm going to call the u term, if I'm going to select that to be x, then the only thing that's left over that can be dv, or the derivative of v, would be e to the x power, or e to the x dx. So if this is u, then all of this right here must be v prime, or dv as it's written here. So that's going to be e to the x dx, e to the x. There we go. So coming down here to get du, you do exactly what it says. You take the derivative of x. Well, the derivative of x in this case would be just 1 dx, or dx. Well, here now I'm going to go up this way and I'm going to integrate. I'm going to take the antiderivative of e to the x. Well, that's easy. E to the x, the antiderivative of e to the x is just going to be e to the x, but without the dx part. Okay, so now we have the u and the derivative of u and whatnot that we need for our equation. So again, I'm going to just go ahead and write it out one more time. We have the integral of u times v prime dx to be equal to u times v minus the integral of u prime v dx. So in this case, we have x to the ex power dx being equal to, in this case, the way that we set it, u times v, in this case, looking at what we have. The u times v, these two get multiplied together for that first bit, so that would just be x times e to the x power minus the integral of the derivative of u. The derivative of u in this case is the dx, so these two are, so the derivative of u and v are also going to get multiplied together, so these two are going to get multiplied together. Okay, and the easiest way to write that, 1 dx times e to the x would actually be, it would be easier to kind of reverse that. Instead of saying u prime v, it would actually be easier to say v times u prime dx. And that will give me e to the x times 1 dx, like so. Okay. So now we just kind of work through the problem and see what we wind up getting. Well, x times e to the x, there's really nothing that we can do with that. But this bit here, we can actually integrate this. And that's what we're going to do. We're going to go ahead and integrate the expression e to the x dx. So that's going to, so the antiderivative of e to the x dx will give me minus e to the x. And of course, because this is just an indefinite integral, we don't know any numbers that we're trying to evaluate it for, we will say plus our constant in this case, and this would be your final expression for the integration of x times e to the x dx as your integrand. So moving on to the second example, I'm going to encourage you to go ahead and pause the video and try seeing what would you determine to be the u, the v, the du, and the dv in this problem, and try working out the problem from start to finish and just see what you get. And then when you're done, hit play again and see how I did it. So presuming that you've paused the video and tried all of the problem on your own, let's go ahead and take a look and see what we have here. Okay, let me pick a different color from what I was using before. Let's try and get this greenish color here. So remember, all of this is going to be equal to u times v minus the indefinite integral. Come on, pen. Oh, it is not wanting to cooperate here. All right, let's just erase the whole thing. U times v minus the indefinite integral of u prime v dx. So the u and the v, remember, the u and the v are going to come from the original problem. Okay? So in this case, u is going to be the, and this is not written super great. This should be the natural log of x in parentheses like that. And that's how I'm going to say here, the u is going to be the natural log of x. And so the derivative of u to get du, the natural log of x in this case would be 1 over x times dx. So if the natural log of x is going to be, if this bit here is u, then the only thing that's left over to be the v prime, or dv as it's kind of here, is going to be dx. So now we take the antiderivative of dx, which would just be 1x. So now we know all of the bits that we would need to try and substitute into our expression. So let's go ahead and write it out. Let's see, I think we have enough room to kind of keep doing it here underneath this equal sign. So u times v, in this case, will be the x times the natural log of x. I think that'll be the easiest way of writing, or natural log of x times x. I think putting x in front will be the easiest way of seeing it. X times the natural log of x minus the integral of u prime times v. That will be 1 over x. That'll be x times 1 over x dx. There we go. And now we can simplify. So to the left of the integral, where it says x times the natural log of x, there's really nothing that we can simplify there. So we have x times the natural log of x. But in the integrand itself, x times 1 over x, well, that whole thing will just simplify to be dx. And just like in the last example, at this point, the integrand is as simple as it will get. So this is where we take the antiderivative of dx. So we'll have x times the natural log of x minus 1x. That the antiderivative of dx will be 1x. And now that we've taken the antiderivative, we will, and there's nothing else that we can kind of do to the problem unless you wanted to factor out x, which I don't see is necessary. We add our constant at the end, and we're done. Okay. So let me just check time real quick. Here we're about 16 minutes. So I'm going to go ahead and pause this video here, and we'll pick it up with a second video, so that way it's not going to just be one massively long video for you to have to work your way through. But if you have any questions, please let me know. Get in touch with me through email, comments in the Google Classroom, whatever is easiest. Google Classroom is probably easiest for my students. But anyway, until then, thanks for watching and take care.